Hello folks, we are coming to the part 10 video of the exercise 4.1. From here on we are going to shift from the usual equality and inequality problems to this multiple kind of problems. So let's see this 19th question. What does it say? It's our part 10 video. N into n plus 1 into n plus y is a multiple of 3. You've got to show that. So let Pn represent the given mathematical statement. Step 1, to show that P of 1 is true. That means you've got to show that 1 into 1 plus 1 into 1 plus 5 is a multiple of 3, is a multiple of 3. We as such don't require the LHS. So we'll just consider this term. So we consider this term 1 into 1 plus 1 into 1 plus 5. What does it come to? It is 1 into 2 into 6. It is a multiple of 3, because this is like 1 into 2 into 2 into 3 is a multiple of 3. So P of 1 is true. So no LHS business. P of 1 is true, and that's how we go to the step 2. Assume that P of k is true. That means k times k plus 1 into k plus 5 is a multiple of 3. What do we understand? This means that is, or therefore k into k plus 1 into k plus 5 is something like 3m, multiple of 3, right? We've done lots of this in the first chapter in the 10th standard, right? Let's see how this goes on expansion. This is k squared plus k. So k squared plus k multiplied by k plus 5 is 3m. That means if you overall expand, k cube plus 5k squared plus k squared plus 5k is 3m, or k cube plus 6k squared, all that let's push it on the other side. K cube is 3m minus 6k squared minus 5k. We could use it, k cube equal to this. Then we can think of the step about pk plus 1 to show that pk plus 1 is true. So what have you to show? You have to show that k plus 1 into k plus 2 and k plus 6 is a multiple of 3. I hope you understood how we got this, where k comes k plus 1 plus 1 plus 1, k plus 2, k plus 1 plus 5, k plus 6 is a multiple of 3. So let's start by considering this and let's see what comes. So we consider k plus 1 times k plus 2 into k plus 6, and let's expand this. First let's expand these two terms. So it's going to be k squared plus 2k plus k plus 2 and k plus 6, and here it's like k squared plus 3k plus 2 to be multiplied by k plus 6. On further multiplication, it's k cube plus 3k squared plus 2k plus 6k squared plus 18k plus 12. So let's see how these are coming up like terms, k cube plus 9k squared, 20k plus 12. Now we should be bringing this term back there. K cube, let's replace by this. It will become 3m minus 6k squared minus 5k. We are replacing k cube, and remaining terms are as it is, 9k squared, 20k and 12. Why we got this? We got this from 1. Okay. Then let's club up the terms. So minus 6 plus 9 is plus 3. Then minus 5 plus 20 plus 15 plus 12. Right, when we got the terms like that, k cube we eliminated, we took the previous thing and put it there. Then what we do is, when we observe this, it's very clear to us that 3 is a common factor. Here m stays, here k square stays, 5k and 4. So this whole term is a multiple of 3, 3 into something, right? So it's very clear that the given term is a multiple of 3. So what happens is, therefore, k plus 1, k plus 2, k plus 6 is a multiple of 3. So what happens? Therefore, P of k plus 1 is true. Yeah, P of k plus 1 is true. So from steps 1 and 2, given mathematical statement is true by PMI. So this is how we are going to solve these kind of problems. That was our problem number 19. Identical problem is a problem number 20. So let's take that up. First let's have this erased and then let's see how that goes. Here the shortcuts are not going to work because lots of work is there to be done. So this is our problem number 20. And let's take the problem. What is it? 10 raised to 2n minus 1 plus 1. Hope I remember. 10 raised to 2n minus 1 plus 1 is divisible by 11. Once again, I'll check in case the ones and plus ones. 10 raised to 2n minus 1 plus 1. Yes, it is divisible by 11. That's our question. So let's see now how that's going to work. So let Pn represent the given mathematical statement. To show that P of 1 is true means it means that 10 raised to 2 into 1 minus 1 plus 1 is divisible by 11. You have to show. It's a multiple of 11. Same thing. So we considering 10 raised to 2 raised to 10 raised to 2 into 1 minus 10 raised to 2 into 1 minus 1 plus 1. What does that come to? This is 2 minus 1, 1 plus 1. So 10 plus 1, 11. 11 is 11 into 1. So therefore 10 raised to 2 into 1 minus 1 is divisible by 11. That's why P of 1 is true. Okay, quite obvious. Assume that P of k is true. That means 10 raised to 2k minus 1 plus 1 is divisible by 11. Let's make it convenient. 10 raised to 2k minus 1 plus 1 is some 11m. Right. So writing this is as good as writing 10 raised to 2k into 10 raised to minus 1. Why a raised to m into a raised to n is a raised to m minus a raised to m plus n. So, or a raised to m minus n, you could have written it by 10. That way also you could write, because a raised to m minus n is a raised to m by a raised to n. Maybe you can write it like this, 10 raised to 1 plus 1 is this. So what happens? 10 raised to 2k by 10 plus 1. Sorry, let the plus 1 go on the other side. Already 11m is there. So let the plus 1 go on the other side. So it will become minus 1. Then let this 10 go on the other side. So what will happen? 10 raised to 2k is equal to 10 times 11m minus 1. This is what we are going to use in a later stage. So what you have to show to prove that P of k plus 1 is true. That means, what does it mean? It means that you should show 10 raised to now 2k minus 1. It's going to shift to 2k plus 1. And why we get it? K replaced by k plus 1. So 10 raised to 2k plus 1 is divisible by 11. Right. For our easy work, let's consider 10 raised to 2k plus 1 plus 1. That means a raised to m plus n is a raised to m into a raised to n. So 10 raised to 2k into 10 raised to 1 plus 1. 10 raised to 2k we know by 1. We know it is 10 times 11m minus 1, and this 10 is also there. So they both will get multiplied here. So 10 into 10, why we got this? We got this from 1. Okay, 10 into 10, 100. 11m minus 1. We have replaced this, okay. This much has come from replacement, plus 1. So 100 into this, 100 into this. 1100m minus 100 plus 1. Minus 100 plus 1, minus 99. So 11 times 100m minus 9. Divisible by 11, multiple of 11, 11 into something, right? So it's very clear to us. Therefore, 10 raised to 2k plus 1 is divisible by 11, which means that therefore P of k plus 1 is true, and from steps 1 and 2 given mathematical statement is true by PMI. So that's how we have done the multiple and divisibility problems. More problems are there that we are taking it up in the next part. Thank you.